For those that just walked in, I was just saying there are issues with the quiz. Don't worry about the grades because we're giving everyone 100 for the first quiz. You should be able to see the missed questions, and right now it's not working for us to see the missed questions. We're trying to fix it. Okay, well, hi everyone and welcome to section. So you'll see a QR code up here if you want to go ahead and scan it. This is going to be my way of like keeping attendance here. So attendance is not required for section, but it is encouraged. And I kind of think of myself as like the mother duck of this class, and you are my little Oakham ducklings. I want to make sure the ducklings don't like wander off and fall into a creek or something. So it's just helpful for me to see like who is showing up and like how it's going. This also has a few like intro questions that are optional. We're going to do some introductions as part of section today for the first one, and it's just kind of getting a written record of what you will probably be saying. Cool. Well, I'm going to start off by giving you a little overview of what we'll do in section today. We're going to start off talking about what the kind of first page of all the section notes looks like. And then we are going to, after that, pivot to a PowerPoint where we go over a bunch of like the boring logistics, and it will be a bunch of me talking and answering all of your questions. I hate that it takes up so much time, but it is something that I think is going to be necessary and useful. So normally the way section works is we wouldn't have all this, and I would present this first page, and then we would take like 3 or 4 topics from the lecture and kind of do a deep dive on it and do some practice and some review of it. Because we have like less time to do actual content today, what I've done is we are going to be doing the basic skills for organic chemistry, which is like formal charge, skeletal structures, things like that. And then we are also going to talk about resonance. The ones that we are not going to talk about are probably the ones you feel worse about, which is kind of, So it's nomenclature and conformational analysis, which are both new. The reason why I'm doing this is because if you do not get these skills down quickly, then tomorrow's lecture will be hard and everything else will be hard. These are skills that are foundational to the rest of the course, whereas these are like one-off types of questions. Like you will have a 5-point naming question on the test, for exam 1 only, really. You're gonna have like a Newman production question, which is a distinct type of thing, but it's not gonna be like foundational to your understanding of the rest of the course. What I've done is I essentially made my section notes for it, so like I here have kind of like a Yossified table of the like nomenclature things, and I have a QR code for a video that I made truly last night in Cabot, where I just kind of talk through this, and then we work an example from the problem set together. We're just verbally talking through it. And again, there's nothing new in this. There will occasionally be things in section where like I will present a more formalized or colorful version of what you see in lecture, but I'm not going to be teaching you new things in here, just new ways to think about things. So, similarly for conformational analysis, I have a whole like lesson and a video here, so you can check these out on your own time. The other reason why I'm not doing conformational analysis in section is because 3D things, it's very idiosyncratic how each person learns it. Like, one way of explaining things is not going to work for everyone. And the best way to learn this is to build a model kit, like use a model kit, build a molecule. So can I see a quick show of hands? How many people have model kits? Okay, people in the back, what's up? So there are model kits available in Cabot. If you like, I think give them your ID or something, then you can get a model kit and use one. The ones that are listed on the Coop are crazy. It's like $200. No, these are like little Legos. Get one from Amazon for like $15, $20 if you can, or borrow one from Cabot, or use a friend's. But like you should not go through this class without playing with a model and like seeing it for yourself, because that's the way you're going to learn the 3D structure. This is most important for lecture 4, which is going to be next Wednesday. Remember, next week's a little bit weird with the July 4th schedule, so just consult the course schedule on Canvas about that. But you will want to have or have access or have a friend who has models by then to be building things and seeing things. Does that sound okay? Work. Cool. So the way that the kind of first page of section notes typically work, I'm always going to have an attendance QR code, and then I'm also going to have like a little feedback QR code, and you don't have to do this you don't do it now. It's like at the end of section, what worked well, what didn't work well, because I make a lot of changes each year, and I try to like do a lot of work on these section notes, which hopefully you will kind of see show through. So the QR codes are there. Then you have a 29-page, like 3-hour lecture on Tuesdays, and it's really hard, one, to pay attention that long, and two, to figure out what's important or kind of the structure of the lecture. So I just normally present a like outline of the main topics from the lecture and a little code to tell you how important things are. So basically here, this thing in gray, so geometry, the electron domains, VSEPR, molecular geometry, we're not going to have a question on the test that explicitly tests that. I mean, it's still something that you need to know and be aware of, and like you're going to use that when you do hybridization, which is something that we're going to explicitly test. But we're not going to give you a question that's straight up this on the exam. So I've kind of marked that out as gray. It's less important. Whereas like resonance, she's going to be a main character this summer. She is going to be in every lecture. She's going to be probably, she's going to be present in maybe half of the exam questions. She's like everywhere. And that's why we're going to talk about resonance today. Similarly, like alkane nomenclature, conformation analysis, we're going to test it, but they're more one-off. Functional groups is a bigger, more substantial topic. And functional groups we're going to do at the beginning of section on Friday. The functional groups used to be part of lecture 2, and then Tim keep trying to squeeze them into lecture 1, and I'm like, just move them to lecture 2. It's fine. But yeah, so that's going to be coming, and it's going to be like a whole thing. Like, I'll get you together on functional groups. We'll have a lot of color coding. Cool. So that's the outline. Then you might have heard people be like, organic chemistry is just memorization. Those people are lying to you. You might also hear people say, you don't have to memorize anything in organic chemistry. Those people are also lying to you. You will have to memorize some things. And so I try to be very explicit about the things that we expect you to have memorized. And so we are typically not going to ask you to memorize crazy things. And if it's something that I think is a little crazy, I'll let you know. Like in lecture 2, there's something that's a little bit crazy where we are going to ask you to memorize like 10 pKa values. And like, we're going to talk about why, and like, I'm going to go through it with you. But like, electronegativity, you don't need to memorize the values. You just need to know that electronegativity increases up and to the right. Yeah.
Do we need to know like the specific order of the fluorine and oxygen, just that it's like up?
Yes, just up and to the right. You need to know like master table of bonding hybridization. You need to know the nomenclature names that we introduced. Terminology of like eclipsed for staggered and gauche that he introduced yesterday. The functional groups we're going to do on Friday. Do not memorize like the energetic cost of HH eclipse is 1 kcal per mole. So I'm kind of trying to split up into things that you could just make flashcards for, and then skills to develop, things that you're going to have an eye towards when you're doing the problem set of like, oh, this is something I need to get good at. I also typically include some like memes, like these are some XKCD, I think I got that order right, comics about like your extended NFPA hazard diamond. Normally you have like flammability, health hazard, and stability reactivity. You also have the street value. You have the number of federal agencies who want to know if you have any of it. How much of a hassle is it to dispose of? But just like little comics. Or this is like, what if bonding was based on just like typography? So like carbon can make 2 bonds because it has 2 little points, and so we can make a hydrogen here. This is not how carbon bonds, please. I know you all know this. But they're going to be more memey in other ones. This one was just like, I don't know, kind of like periodic table. Cool. So this is the first page. The first page in most other sections after this, I will not spend time on. I'm not going to go through each beat of like things to memorize, the outline. It's more for your reference for when you're studying later. Questions on this kind of first page of the section notes and what our game plan for today is? Yeah. Things are highlighted are like between the gray and the yellow. So like, I mean, they're there, but it's like, I don't know, alkane basics are kind of included in alkane nomenclature. They're connected. Yeah. And like these things are what make up conformation analysis. So it's kind of hard to say when there's like subcategories. Other questions? Oh, yeah, totally. Okay, so I'm going to now switch over to this PowerPoint, and it will probably take a second, so please feel free, actually, not feel free, turn to your left and right, say hi to the person you're sitting next to, talk to each other. Okay, so let's talk through kind of the logistics that we're going to go over. We're going to do a little bit of introductions and go around the room, say things. Then we're going to talk about the kind of the course setup. So like, what do you need to turn in? What are exams like? How are you going to be graded? How can I ask for help? Then we're going to talk about the resources available to you and some advice that I have just for the course. And then we're going to hop back over to the iPad and like go through actual course content. Full disclosure, this is probably going to take like 40 minutes because it's a lot of information and there is a lot of like logistics stuff for this class. I'm going to try to go as quickly as I can, but also I want to be answering your questions as we go, because if you are thinking the question, other people probably also have it. So, hi, welcome. You all have chosen to do a difficult thing. Like taking organic chemistry is kind of notorious for being something that's difficult and taking a lot of time, but you have also chosen to do it under a time crunch of a like 7-week shortened semester. So bold choice. My first organic chemistry class at Harvard that I went into, they had kind of on the door when you entered, abandon hope, all ye who enter here. And that's not what I want the vibe of this class to be. Like, it should not be a hellish experience. We're here to help you, and we want you all to be working together as a team to like knock this content out of the park. No matter when you take organic chemistry, it is a lot of work, but if you are a person in this room, if you are at Harvard University enrolled in organic chemistry, you are someone who has the ability to learn organic chemistry. Like, that should not be the question. I think the question a lot of times for students is the context that they are taking organic chemistry in. So if you are a student that is taking organic chemistry while also taking another class, or working, or doing lab research, like organic chemistry kind of takes over your life no matter when you take it. And so when you're in this kind of time pressure, time crunch summer, it's even harder to balance that. And so like and one thing I'm very familiar with working on this course is having conversations with students to help make a plan and try to kind of figure out how to make OChem work for them. And sometimes that involves like reassessing and taking it in the fall, which it sounds like it's like a very big dramatic thing. It's just what's going to be best for you to succeed, because all of you can do this. OChem is work, but not that scary. Tim's great. He, I think, is a great teacher. His course reviews come back that he's like very clear and explains things well. He thinks a lot about how to present information, and also he just like cares about students, and you don't always see that from science professors. And then his personality is this kind of like dry, awkward British humor that has a lot of like dad energy to it. And so I would say like lean into that and try to enjoy lectures as much as you can. No one wants to be there for a 3-hour lecture. Not Tim, not me, not y'all. 3-hour lectures are the worst way to learn something. It is the only way that Harvard Summer School lets us do this. We would not do it this way if we had the choice. So, cool. So, who are y'all? Why are you here? So these are the questions that were on the little survey QR code if you already filled that out. But who are you? Pronouns, where are you from? This is kind of a unique class in terms of like where students are at in their education. So you're going to have a lot of Harvard College students who are just taking classes here in the summer, like as part of their normal college time. You have high school students who are here with the secondary school program that are like staying in the dorms and taking classes. And then you also have post-baccalaureate students who are in, typically they already have an undergrad degree, and maybe they are taking this class for like a pre-med, like post-bac of like, they got a government major, but now they want to be a doctor or a dentist or something. And so I actually think it's kind of cool because it puts these groups of learners into contact with each other that don't normally work together. And it just creates kind of a more dynamic environment. So the next question is, where are you at in your education? And then why are you taking this class? And I'm not precious about organic chemistry. Like, I have a lot of enthusiasm, but that's just who I am. It's not because it's organic chemistry. I had the same enthusiasm for calculus. So if you're just taking this class for pre-med, if you're just taking this class because it's a required class, great. That's the reason I took OChem. That's the reason I was a chemistry major. I was like, what satisfies pre-med things? I guess I'll do that. So where do we want to start? Oh, actually, one last thing. I'm horrible with names. Truly horrible. Like, I've had instances where I've been walking down Oxford Street. Someone has come up to me, said, "Hi, Colton," and then asked me specific details about my personal life. And I, no idea. Just kind of eyes glossed over. I will learn everyone's name by the end of the course, but I need some help, especially at the beginning. And so the general policy that I'm going to say is, if you come up to me to speak, or if you ask a question, or if I call on you, say your name and then say whatever you have to say. Like, "I am blank, my question's this." And do that until I start prompting you with your name. So when I'm like, actually, I don't think I know anyone's name. What's your name? Georgia. Like, if I'm like, "Hey, Georgia, what's your question?" Then after that point, you don't really need to keep doing it. But then if I'm like, then yeah, help me out. Cool. So which corner do we want to start in for introduction questions?
I can start.
Work.
My name is Abby. I'm from upstate New York. I'm going to be a senior, a rising senior at Harvard, and I'm taking this class because I'm not.
Nice. Welcome.
Hi everyone. I'm Lonnie. I go by the She series. I'm from Alhambra, California. I'm a junior at the college studying biological engineering, and I'm taking this class because I'm pre-med and it may be fun. Yay!
Work.
Hi guys, my name is Adrian. I'm from North Carolina. I'm taking a sophomore at Harvard, and I'm taking this class because I've gone into dentistry.
Nice.
And not only is it a part of it, but it's also heavily tested on from a DOT.
Well,
I learned it.
So for those who don't know, like, you probably have heard of the MCAT for med school. So dentistry, they have the DAT exam, and they're doing crazy things. Like, they will present angles, like 4 angles that are 28, 29, 30, and 31 degrees, and say, what's the smallest angle? And visually, you just have to, like, know the difference between a 28 degree angle and like a 32 degree angle. Crazy stuff. Welcome.
Alright, hi, my name is Daniel. I'm from Florida, and I'm going to be sophomore next semester here, and yeah, I'm here for pre-med pretty much.
Work.
Could be fun after that.
Could be.
Hi, I'm Georgia. I usually look around. I'm from California. I am a rising sophomore. I'm taking this class as a requirement for neuroscience major, and I'm going to be pre-med, but I'm excited.
Work. Nice.
Hi, I'm Alyssa. I'm a rising sophomore at She series. I'm a rising sophomore, and I'm pre-med in neuroscience as well.
Work.
Hi everybody, my name is Lisa. I'm from Northern Mariana Islands near Guam. I'm a rising junior at the college studying neuroscience and econ. I'm taking this class because it's also a pre-med requirement and it could be fun.
Ding dong. Also, neuroscience and econ, a natural combination.
Right.
So the other TF for this course, his name's Luke, and he just got added to the course yesterday. He was at lecture, but I hadn't met him yet, so I didn't introduce him. We will introduce him tomorrow. He was like pre-med and an econ major, and so there's a lot of like the interdisciplinary. I think there's one other student who's doing like econ and science.
There's like anyways a PLS.
Work.
Like
Yeah. Nice. Nice. Well, welcome.
I'm Danny. I use she as pronouns. I'm from New York, and I'm doing a United States class. And
Danny. Sorry, I was trying to find your name on my like little list, and I was like, New York,
Oh,
postback. Yes. Wait, where'd you do your undergrad?
Western is in
Oh, okay, nice, cool. Welcome.
Hi guys, I'm Charlie. I'm from South Carolina. I'm a sophomore at college and senior at Constitution College.
Nice.
I'm Tommy. Ethan. Oh yeah, I'm from the South.
Okay. And where'd you do your undergrad?
Barrington College in Vermont.
Nice, nice.
Very, very small. It's like 500 people. It's like 12
Okay. What was your major?
It was international relations.
Okay.
Very good.
So we love a pivot. Work. And then in the back. Work. Nice. Welcome. Wait, you're in high school and you're already thinking about MCAT? It is the way it is. Work. And what was your name one more time? Lourdes. It's not. No. I was just finding on the list. Work. Just to check, is there a Forrest here somewhere? Is there a Sergio? And is there a Joseph? And Vishal. Work. Cool. So, a little bit about me. Because I made a PowerPoint, I get to have a slide about myself. So, my name's Colton. I'm non-binary. I take any pronouns. I'm from Georgia. I'm a Southern Belle, a Georgia Peach. I did my undergrad here at Harvard College. I was in the social class of 2020, and then something happened in 2020, and I ended up graduating in 2021. My degree was in chemistry and music, so very Hannah Montana, best of both worlds. And then I thought it was kind of funny because it was pandemic time when we graduated, they sent us an email that had a PDF of our degree. And so now I have a JPEG on my computer that's just, quote, my Harvard degree, I guess. So that's fun. I was in Courier House here, and I transferred from Elliott, which is uncommon. But I love Courier House. It has retirement home vibes, and I liked the calming energy. When I was a student here, I did a lot of like musical theater, music directing as my main extracurricular. So like this is a production of Musical Chicago I worked on. This was a musical adaptation of Shakespeare's The Tempest that a friend of mine wrote the music for. It was like experimental theater, and we did it in the Adams House art space. And then right after our last performance, the building was demolished. It was very dramatic. And I think they might have rebuilt it. I don't know. And now one of my main hobbies is I see a lot of theater. So I see like 60 to 70 shows a year. And as part of that, in the summer, I have a kind of intense schedule of after Friday section, I hop on a train or car and train, and I go to New York for the weekend, and I see like anywhere between 3 and 6 shows and visit friends and things. And then I travel back Monday morning and then come straight to Help Room. So if I seem tired on Monday, probably am. Other things. Oh, I work as a tutor for math and science, and I like tutoring just because I get to kind of move between a lot of different topics. This is my 6th year TFing for Chem S17, so obviously I like being here. And then I started taking classes at the University of Georgia near where I live, and I was like, Harvard doesn't really do biochemistry. Like they have like all the science, they don't have like a biochemistry degree. And I was like, no one taught me about hemoglobin. I need to learn about hemoglobin. I want to learn about hemoglobin. And so I started taking biochem classes. I also was like, I miss math. And like proofs, and so now I'm only like a handful of classes away from getting second degrees in math and biochemistry for undergrad degrees. I'm also doing like vocal performance stuff, and then eventually I will want to do some PhDs. No idea exactly, but essentially I like school. That's the basic premise. Then I have a sweet dog, Daisy, that's in Georgia, and I miss her very dearly. She's with my father. But it's nice to meet you all. Welcome. Thanks for being here. Now it's going to be much more boring. I'm so sorry. So let's, and I will try to go as quickly as I can through this, but we also have to be thorough. So the lecture review quizzes are not working. Normally you should be able to see your answers. I've already said this. Tim said that he sent me an email saying that he just changed the setting like 15 minutes before our section started. And so hopefully now you will be able to see your answers, but we'll see. What we're doing for the first lecture quiz is everyone just gets full points. So don't worry too much about it. Then we have problem sets. I already gave you kind of my spiel yesterday. We have skill builders, which you have the answers to, and challenge problems, which you don't have the answers to. You have to do all the skill builders on the problem set when you turn it in. You can't like leave pages blank. And it's just to kind of reinforce the idea that the practice problems are really necessary for this type of class. P-sets will be graded based on effort. So if it looks like you gave the page an honest attempt and you've worked everything out, even if there are some things that are wrong, you're going to get a full point for it. If it looks like you worked about half the page, we're going to give you half a point. If it looks like you kind of scribbled a sentence and like wrote half of a structure and then didn't really kind of complete an answer, then you're not going to get a point. And so it's based on effort. The other thing about this is if you're used to the pre-med classes at Harvard during the semester, this is different in that we have a much smaller course staff than like a typical pre-med class would have. So normally there would be like a team of 15 to 20 people and you would have office hours all these different times, and office hours would be smaller because you have so many offered. We have to do things a little bit different just because we have a smaller staff, and essentially we had the choice between kind of developing better like study materials for y'all and giving more individualized feedback on problem sets. And by we, I mean me, I have chose to be developing resources for y'all to be using. And so like that's kind of the compromise here of this class of you're not really going to get feedback on your problem set. With that, what that means is you need to budget some time after you turn in the problem set and the answer key is released to go through those challenge problems and make sure that to check your answer and make sure that you understand what's going on. So I like to give kind of a disclaimer about that up front. Late work is accepted up to 24 hours late for 50% off, and then after 24 hours, no credit. That's an intense policy. It is. And it's just because the pace of the course. Like immediately after, truly immediately after you turn in a 47-page problem set, we're going to turn around and give you a 38-page problem set for problem set 2. And it's just the pace of it. And so if you are still trying to finish P-set 1 2 or 3 days after the fact, you are already so far behind for the next P-set that it's just not sustainable. So it's better to kind of like cut a loss there. If there's an issue submitting your work, send me an email with a PDF or with whatever you have of your problem set as soon as you can. So like if I get an email from you at 12:30 and it seems clear that you've tried to do this and your PDF's like 50 megabytes and so that's why I want to upload, yeah, sure, I can like deal with that and help you and it won't be counted late. But if you like come up to me after lecture the next day, you're like, hey, so this P-set thing didn't happen and I have no email and no record, I can't help you as much. And so help me help you by just being communicative. The P-sets are submitted all via Gradescope online. And so if you're doing a paper P-set, you need to scan it. Also, if you need a paper P-set, we still have a few more copies up here if you want to grab one at the end. If you're doing a like tablet, you should be good to just like export the file and upload it. But these are all the things you have to turn in for lecture. Lab, I have no idea. Lab is very much not my circus, not my monkeys. And so if you try to ask me a question about lab, I probably can't help you. Like, I just don't know things. So Emma's going to be the kind of contact person for that. Questions on things to turn in? Yeah. It's typically only a problem if there is a setting that is not compressing the image. So if like you are like, or sorry, are you talking about for a tablet?
Yeah, for example.
Yeah. No, it's never an issue with tablet. It's only an issue when people are taking pictures. And if there's a setting that doesn't compress the image, suddenly you have 47 pictures worth of information and it's just a big file. Also, name one more time? Tommy. Cool. Other questions? Things to turn in? Okay. Exams and participation. So exams are 65% of your grade in this class, which is a lot. Exam 1's 15%, exam 2 15%, final exam's 25%. Exam 1's going to be over the first 4 lectures. Exam 2 is over the first 9 lectures, and the final is over all the lectures. So there's overlap here. And it's kind of just because organic chemistry is inherently cumulative. Like the things that you learn in the first lectures, you're going to be building upon later. But we're not going to be like explicitly testing exam 1 content on exam 2. So for example, the Newman projections thing that y'all did like towards the end of class yesterday, that will be an exam 1 question, and it will not be an exam 2 question. But it's like a skill in your arsenal, and everything comes back for the final. I almost don't need to say this, but exams are graded on correctness. I've had the question in the past, since PSETs are graded on effort, not for exams. So group exams. So 2 weeks from tomorrow, which is when your first exam is that right? Yeah, that's right. Y'all are going to come in the normal lecture block of 3 hours, and this is the way it's going to work. We'll probably start around 8:45 to give people time to kind of get in and get settled. And you'll come in and take a 90-minute individual closed note exam, just on your own, like a normal exam for any other class. Then we will collect the exams, and y'all will have a 15-minute break. During that 15-minute break, you are going to check Canvas, and you'll find that you will have been assigned to a group. And you're going to be randomly assigned to groups, and you're not going to be able to choose your groups. I'm so sorry. We tend to get like a better distribution when people like are randomly assigned versus like if all the strongest students in the class get together and don't work with students who are weaker in the class, then group exams vary. And group exams are supposed to be a helpful thing. Specifically, like we want you to have the chance to re-engage with an exam and to turn anything that you missed into something that you learn. Like you learn in the moment about why you missed it. And so what's going to happen is once you're in your groups, we're going to give each group 1 copy of the same exact exam that y'all did as individuals. And then as a group, over the next hour, you'll work through the exam and submit 1 copy for the group. Now, when you are working on the group exam, y'all are talking to each other, and there is going to be course staff circulating. So we are going to be around, and we're not going to be able to explain things to you in terms of like, if you ask me, how do I do this? I can't do that. What we can do is we can settle debates. So if, Georgia, and then Daniel. So let's say y'all are working in a group, and y'all are arguing about the hybridization of an atom, and you say it's sp3, and you say it's sp2. I can be like, it's sp2. So it's that kind of thing of like, y'all are supposed to be discussing it, and if y'all disagree, we can kind of like settle the debate. And then we might like say a little thing, but we can't tell you, okay, first do this, second do this. For your actual exam score, for exam 1, it's going to be 80% your individual score, 20% your composite score. And it's not going to hurt your grade, the group exam. So if you are one of the people that's going to come in and score like a 98 on the individual exam, and your group exam comes out to like a 95, we will not lower your score. That's only happened, I think, 2 times in the history of me being with this course for 6 years. Typically, the group exams helps everyone. It's typically a grade booster for everyone. And then there's no group exam on the final exam. So the final exam is only individual, and it's about 1.5 times the length of the midterm, but you have double the time to do it. Whew. Last 2 things on exams, and then I'll take some questions for it. So we want to reward you learning the material, and sometimes that doesn't happen the first time you see content. So let's say you don't do well on the first exam, but then you study those questions, and when those questions come back for the final exam, you've got it together and you can do it. Then we want to reward you learning that material. And so whatever your best exam score is, we are going to give you an extra 10% of your final exam or final grade for the class as that best exam score. And that's how we get the 65. This is just 55 up here at the top. Last thing, we're going to release practice exams. We'll release them about 5 days before the real exams with very detailed instructions for how you should approach them. You will also have a problem set that's due at the same time, so that's why we're kind of waiting to release them, and we'll kind of give some guidelines about it. They will be past exams, so they will be real exam level problems. Then last thing, participation, 10% of your grade. Half of that's going to be the in-class poll questions. You just have to answer half of them. It doesn't matter if they're right or wrong. And then the other half is the lecture review quizzes. So like lecture review quizzes are 5% of your grade. That was a lot of information. Questions?
How does the testing work with the college?
I will be sending out an email in the next like week about it. But essentially what will happen is I will be in one of these rooms around here with the students who have the extended time, and we will start early for the individual exam. And then we're having the students with exam accommodations do the group exam with everyone else. And if they don't want to do that, then they can just take their individual score, and that is fine. It's just it's hard to reproduce the group exam, and also in the past, no groups have struggled with completing it because you have like 4 people working together.
And then we have like distraction reduced testing for a way to like
So
have a less sensory overload environment.
I'll have to look into that. So it's going to be easy to do for the individual, but can you actually send me an email about that to remind me to look into it? That's just a general thing of like, my email is my to-do list, and so if I don't have an email about it, it's not on my radar as a thing to be doing. So generally, I will end most conversations with students who have, send me an email about this. Other questions related to, yeah?
So for the lecture review quizzes, was it just this first week that it has to
Yes. So it's not even this first week. It's just this first one because we've messed up the settings on it. So hopefully those will be fixed and we won't have the technical problems going forward. But yeah, those are graded on accuracy, but you have 3 attempts or open note. And so it should be a thing where it's really easy to like retake it and get it up to 100. Yeah. And Tommy? Okay. Yeah. Allison. I mean, they are past exams, so the lectures haven't changed. Yeah. And also the exams follow a very predictable like format of like you're going to have one synthesis question, one box problems question. Like you're going to have very similar kind of types of questions, so you should know what to expect going into it. Yeah. Cool. Yeah.
Lonnie, I have a question about the poll everywhere from last year.
Yeah.
I'm confused on how to make sure I get benefit because the whole registration on
That's
campus is-
also a great question. Poll Everywhere is new to me, and Tim is contacting people about like IT support with it. But that, just assume that while all the technology issues are happening, you are getting points. And if it ever looks like that isn't the case, send me an email and I will fix it. Yeah, totally. Cool. Okay, I'm gonna go on to section. I know most of you know what section is because like you are college students here, have taken other classes at Harvard. So it's a chance for review and practice. There's no new material in sections. We talked about the section structure earlier. On Friday, we're gonna have, quote, extra challenge problems. And they're not extra challenging, they're just additional challenge problems. So they're gonna be like PSET level or exam level kind of questions. And it's a chance for us to like see them and work on them and approach them for the first time together. And so they will be posted in the morning, but you're gonna be asked to not look at them before section, just so you can have like a fresh take on it and be practicing that, how do we start a question that we don't know much about. We're also gonna have printed versions of the extra challenge problems that I'll give you on Friday. And we won't do everything with the extra challenge problems, and so there will still be some that you get to do as just like a extra exam practice as you're studying. They don't need to be turned in or anything. I already talked about attendance. My pitch for coming to section is just like, my only job is to help you learn this, and I spend a lot of time making section things. So come to section if you want. Communication via email. I already said I'm pretty fierce about my email. I try to respond within 24 hours about everything. And then don't send a message through like Canvas, just my email address. Then section notes. Okay, so my section notes are a lot. They're very kind of busy, and there's a lot going on. They're very dense. The kind of philosophy behind creating them is I want you to have a condensed resource for all of the essential information from a lecture, just because everything else is spread out. I also want it to be like not ugly looking. So like it is busy and there's a lot going on, but I've tried to like make it look nice at least. They also are primarily a visual aid for me with teaching. So I use my iPad and I kind of zoom in. And so you are not really expected to be able to write on them. And all of the practice that we do, for the most part, are going to be from your homework. So if we get to the part where you're like zooming in on your tablet and you're like, that's really small, just go to your problem set and like do it on the problem set. And I'll always list where it is in the problem set. We can't give printed versions of the section notes because I make them like right before they happen, and also because they have a lot of color and that's like expensive to print. Cool, I think that's it. Anything here? Last thing, or last kind of big thing, resources. So TS, feel free to reach out to me or Luke or any of the course staff. Help Room, I'm going to talk a little bit more about, but it's our class's version of office hours, and they all take place on Mondays. So we will have 2 time slots, one in the morning from 8:30 to 11:30 a.m., and one in the afternoon from 12 to 3. Here we have listed the rooms and also the course staff that are going to be there. You can come to any office hours. You don't have to come to my office hours because you're in my section, or my Help Room hours. One thing to note for the AM Help Room hours is they couldn't give us a big enough room. So like, let's say there are like 20 of you in here, that's B105, one of the Help Room rooms. If like 10 more people come, there are no chairs. And so we have another room that we're going to spread out in. So you might want to check both of them and see kind of how full they are. And if people are using both rooms, the course staff is going to circulate between both of them. Yeah. Danny. Only in person. Yes. If there's like a conflict or something, send me an email. Shoot. Yeah, send me an email and just remind me of that. Okay, other things I've been talking since 8 a.m. Potentially get. We already talked about Model Kit. Do not get the textbook. We don't use it. The OCHEM and second language books. Highly recommend it. It's how I first learned organic chemistry. They really break things down into kind of simple language of like very straightforward descriptions of how to start solving problems and what these concepts are. One thing that's kind of weird about how Harvard teaches chemistry is Harvard does 17 and 27 as their 2-semester OCHEM sequence or Orgo sequence. But really, they take everything that you would need for biochemistry from a year's worth of organic chemistry and put that all into 17, and then 27 is biochemistry. So we do it very weird compared to other schools. Like, for example, lecture 3 that we do here, we're going to be covering reactions that are typically taught at the end of OCHEM 2 in other schools. And so these OCHEM as second language books are written with the other 2-semester schedule in mind. And so I've made a little table that says, hey, for lecture 3, go to the semester 2 book for the OCHEM as second language, and it's these chapters. For lecture 4, it's the semester 1 book and these chapters. And so this is just reference info. And for the people taking photos, this is actually in the PDF of the section notes. There are slides at the end. Yes, all of this is all on the PDF. Mm-hmm. And then if you know the Academic Resource Center, the ARC, during the semester for Harvard, the summer version of it is called the Academic Tutoring Service. And that's like a free tutoring thing that they have. And I believe it launches on Sunday. So after that, you'll be able to request tutoring to help kind of support. Ugh, work. We're so close. I have like 3 slides. Help Room. So this is something that's always been the kind of philosophy of the course, but we've never quite made it explicit. Y'all outnumber us. That's essentially the thing. Like in the other like pre-med classes during the semester, there's a much larger staff. But here we're going to have maybe like 20 to 30 students and 1 course staff member at a time. And so if y'all just lined up one by one and asked questions, that's not going to be efficient and it's going to be frustrating. So what we do instead is we create a space for y'all to work collaboratively. And you are going to be expected to talk and work with the other students in the class before asking staff members for help. So when you come, just like find people, say hi, try to be like, what question are you working on? And if they're not working on the ones you need, go and try to find another person who is working on the question that you need to talk about. and then work together and then come up with a question, and then the staff will come around and answer questions to the groups. We prioritize groups over individuals for questions just to like maximize how much we can help. And we'll also do things like if Danny, work, like let's say Danny's group got challenge problem 3 down and I like talk with y'all, and then, oh no, one of you is Tommy. And then let's say Tommy's group goes to challenge problem 3 later and they come to me asking a question. I'm going to see, like, do you know Danny? Danny and Danny's group is very nice. Y'all should go over and ask them about it. And so you'll be expected to kind of help explain with each other. It's kind of like a co-op approach to office hours of like, we're all in this together. So I just wanted to kind of make that explicit as what Help Room is, just so you don't have other expectations for what it is. But you might still be asking, where can I ask individual questions? Before or after lecture, during lecture breaks, Tim and I are around, and also Luke. Then I stick around for like 15 to 30 minutes after each of my sections, so you can come ask questions then. You can email me questions. If it's like a dense content thing, I might be like, it's better to talk about this, and we can set up a little time. And then the last is, if Help Room is not busy, you can ask individual content questions. But can I get a thumbs up of, do y'all understand kind of the expectations for Help Room? Okay, work. Do y'all think that this is going to be like a good thing or a, oh, I'm not excited about this? Can I get like an enthusiasm thumb meter? We have a lot of middle thumbs. I respect that. It's kind of weird. Think about it as this is like Orgo boot camp, and you are going to get to know each other really well. And we'll see how it goes. Grade cutoffs. So I get so many questions about this, and so I made a slide this year for the first time to actually say it. On the syllabus, we've listed some grade cutoffs, like, for example, the grade cutoff for an A or an A minus is 85. And we don't really say anything about, okay, well, what's an A versus an A minus? And I'm here in doing this slide to tell you, we will not know what that cutoff is until the course is done. Until all the grades are in and we have a big spreadsheet, we will not be able to tell you what the cutoff is. And it changes every year. In the like 6 years that I've done this, the cutoff for an AA minus has been anywhere from an 89 to a 93, which is like a huge range. And it depends on the difficulty of the exams and the course each year, and it depends on student preparation. And so we don't want to just set an arbitrary line if it's going to be this. We want to see kind of how the class does and look for gaps in like the comprehension or in the performance on exams. So the way we do that is by doing grade bends. So if you are following along the slides on the tablet, don't look at it here. But what we do is we would get everyone's final grades calculated as a percentage, and then we would start to look for gaps in the scores. So where do you see a gap, a significant gap between scores where there are some kind of clusters above and below, but then there's a space where no one's really having grades? Yeah. Yeah, right here. So like, see, we have a bunch clustered at 92. This is kind of indicating that those all probably have really similar understanding of the course. And then there's no one for like 1.6 percentage points. And then they have all of these that are kind of clustered together. So that's where we made our cutoff last year. And like, again, if we had a score that was like a 91.8, like that would probably go up, but those kind of boundaries would maybe look at their final exam scores to see, does this level of comprehension seem more similar to the group above or below? And so that's how we decide it. And it's not set in stone, and so I cannot answer your question, and I have no idea what it will be if you ask me what is the grade cutoffs. Yes? Yeah, totally. Okay, and then what about the A minus B plus cutoff? So we've said that it will go no higher than 85. But do you think that we should lower it below 85 for this set of data? Yeah. Would you lower it by 1 or 2 or 3? Y'all are in charge. You're doing all the grades. 3. You said actually the cutoff for an A minus is a 72.
Oh, God.
So the way we put it is we put it here. because we said, hey, there's like a 0.9% gap here, and so this 84.87 seems more similar to the comprehension that the students above got, and so that's where we set it. So we can lower it, but we're never going to make it higher. Cool. I know that that's not like reassuring information to have, because it would be nice to like have a clear target, but it just depends each year. Lastly, my advice, my teaching philosophy, I'm here to help you. I am going to advocate that you get points for things whenever you can. I'm not trying to like take away points or grade things. Yeah, this course kind of like takes over your life when you do it, and it becomes my life over the summer, and I really like it, and I'm very involved in it. And yeah, I've just always had a great time with the class, and so I'm excited to be here and working with y'all. Second piece of advice, which the first one wasn't really advice, it was just like FYI. Second one is 35% of your final grade are kind of gimme points. Like, you should be able to get above 95% on homework lab participation altogether. And that's going to be really helpful and give you a little bit more grade flexibility for the exams. So try to maximize those points. Take the skill builders seriously. If you're just copying down the answers for it, you're not learning it, and it'll kind of shoot you in the foot for the exam. Section 3, which is going to be happening next Friday, because again, remember, next week is weird. It's going to be the most important section. So lecture 3, you learn your first organic reactions. And so this section is going to be focused on how do you study reactions. Because once we get to like lecture 5 and beyond, we're just going to be throwing more reactions at you, and that's the rest of the course. So it's a really kind of like foundational skill. If you only show up to this one and one other section, show up to section 3. Lastly, I recommend making like a schedule for your OChem work, just because it makes it easier to like have, I'm going to be in this place doing this thing at this time. And a sample schedule might look like this, where you have like lecture, section, lab. And then on Tuesday, I would say after lecture, try to get some basic learning done of like, what did I not understand from the lecture? Attempt the quiz, hopefully it will be working. And then maybe start some of the skill builders. And then after section, when we go over content again, I would say try to get all your skill builders and quiz done before the next lecture, like by the Wednesday night here. And then repeat that process for Thursday and Friday. So I think a really great goal for tonight would be to try to be done with the lecture 1 skill builders. I know many of you, or some of you, have lab, so that's not necessarily the most reasonable thing today. But general goals, then you get kind of the weekend to attempt the challenge problems, and then Monday to kind of solidify questions and work on it. So, reach out for help when you need it. We're here. Any questions? And then this will be the end of this. Yeah.
Georgia.
Georgia.
I don't know if you can answer this, but like, how important is like having done the lecture for being able to do the homework?
I don't really know.
Prep before I watch the lecture.
I think. I just don't know. Yeah, sorry. I have no idea what y'all are doing. Like again, not my circus, not my monkeys. Other questions of logistics? Yeah. Yes. Yes, and I think Emma sent out an announcement about it, I think. Work? Okay, let's take like a 2-3 minute break of like stretch your legs, get water, go to the restroom, and then we'll come back and we'll pivot over to actual content. Yeah.
So
Danny,
Danny.
work. Were you the one who's working on Monday?
Yeah, and then I think I was under the impression that this class was supposed to be Tuesdays and Thursdays, so that's why I have meetings I need to be at on certain Fridays.
Yeah.
So I work at BMC, so it's a bit of a commute.
It is, yeah.
But like I can be done. Like, is there an option where like next Friday I don't think I would be able to get back here in time, so could I join it on Zoom?
There are options. I will need you to email me because I will
yeah.
forget everything, but I'll tell you about the options in the email, okay?
Like, yeah. so you don't know if it'll work.
So
or
I
not?
like record myself for
Oh.
it, and so I can give you the video. But yeah,
Okay.
it probably won't be synchronous.
Okay, but that's totally. And you think that's kind of like because you said next Friday, or that would
Yes.
be enough to?
Yes.
All right.
Yeah,
Thank
it's
you.
really just like watch my TED talk about how to study for reactions.
And are they all? Do you record all of them?
I'm trying to. Yeah,
okay.
so we'll see.
Thank you.
Totally. Hi. Yes, right here. Oh gosh. Remind me your name one more time. One more time. You want to write it? Do you want to? Yeah. Or sorry, just what is your name?
Boom. B-F-I-N-G.
Where?
That's my first name.
Okay.
And Molly's my friend.
Oh, nice. Cool. Thank you. Yeah. Have they not? I thought it was in the announcement. I think it's.
Oh wait, I'm just realizing I don't have a tomorrow. I didn't know.
I mean, did you look at?
Oh no, in the email. Actually, in the email, it said they're all in like.
I think
two on or two.
I think then science and future. Check the other announcement and then check the lab page, but it should be on there.
Okay. Oh, is it intro to lab?
But I was
I remember.
Oh,
Yeah.
I
Okay.
might
Lab.
have something.
We all know exactly.
I know they partner with us.
Isn't everyone the same?
No way.
It's all in the same space. It's the same lab.
Because then, like, both of them send it to me, so like, I don't even know.
Okay, so let's kind of circle back up and we will start the content side of things.
I'm pretty sure that sounds good in my head. Now I'm
So, the first kind of big topic that we're going to talk about today are basic skills for organic chemistry. And it's basically taking a bunch of things that you've done in Gen Chem and thinking about how to approach it from an OChem perspective. So the first thing was formal charge. Like y'all have all done this formula of some sort of formal charges. Valence electrons minus lone pair electrons minus bonds. And so you would go and you would count 1, 2, 3, then you would calculate, and then you would be like, the charge. So that's like doing math and doing a lot of thought. And for organic chemistry, you want this to become like a passive visual skill. So for our kind of like frequent characters that we see in this class, you would just see, okay, oxygen, 2 bonds, it's happy, it's neutral. 2 bonds, 2 lone pairs. Carbon with 4 bonds, neutral. Nitrogen with 3 bonds, 1 lone pair, and then halogens with 1 bond, 3 lone pairs. That's the normal. And then also get to know what their charge states look like, again, as a visual skill rather than calculating it. So can we try it here? What's the charge on this carbon? Neutral, yeah. What's the charge on this carbon? Neutral, it has 4 bonds, and the charge on this carbon? -1, because it has 3 bonds and 1 lone pair. So it's this one. Okay, what about the oxygen in the middle? Do other people agree? It is, I just want y'all to say. So positive, what about the one on the right? Neutral. Boop. And then the other one? Minus. Great. That's kind of where you want to get with it. If you are not there in terms of the speed right now, work on the speed with the problem set. Skeletal structures. So some organic classes truly are out here for months doing this. To which I ask questions like, do you not enjoy living? Do you not value your time? That was a bit much. This is what my OChem class did, and it made me hate it because it was so tedious to write out structures. This whole thing took me like 30 to 40 seconds to write out, and it's literally that. in a skeletal structure. And so skeletal structures, get comfortable with them because that is what we will be using and that is what the world uses. So in skeletal structures, every unlabeled end or a kind of bend is a carbon. So this is a carbon, this is a carbon, this is a carbon. And then all of our CH bonds are implied. Lone pairs can be implied or not, but you have to show formal charges. So with that, let's try this example here. So if I didn't have a positive charge on this, how many hydrogens would be on this carbon? 1. And the way that people just did that quickly was they said carbon, we see 3 bonds, we know it's neutral, so there must be a 4th bond. That 4th bond is a single hydrogen. But if I have a positive formal charge there, then how many hydrogens does it have? 0. Exactly. So if you meant for there to be a positive charge but didn't write it, and you're like, oh, I thought the positive charge can be implied, no, like that's not giving us clear information, whereas this is very clear. So how many hydrogens are on this carbon up here? 3. How many hydrogens are on this carbon? 2. Great. That's something that you will practice and get fast at. One sec. And then the other thing is, any atom that's not a carbon or hydrogen, we call a heteroatom. And heteroatoms you always have to draw out. And if they have any hydrogens on them, you have to draw the hydrogens. So you could not, if you wanted this oxygen to be neutral, you could not just leave it like this. You have to include the H on it. You can't imply it. Yes? Yes, I mean, I should include H's. Yeah. Sure, like, I mean, this just looks better, but, like, skeletal structures, like, very formally, skeletal structures are not intended to show 3D structure, but if you can, it's better. And, like, really what's happening is one of these is a wedge, one of these is a dash. Just do whatever you feel comfortable with, but we're not going to, like, count off or anything. If you want to, sure. Yeah. Okay, then if we have a name and we want to make a structure from that, we look for ane, our kind of parent, and then how many carbons is hept as a prefix? 7. 1, 2, 3, 4, 5, 6, 7. That's right, and we're done. Then over here, how many carbons does this chain have? 5. We have pent, like pentagon prefix. 1, 2, 3, 4, 5. And then what is a hydroxy substituent? OH, yeah. So when we're given a name and we have to draw a structure, then we can just start counting from one side and like 1, 2 and put on our OH. And it doesn't matter which side we start counting from when we are given a name. Now, if we have to come up with a name, then it does matter the numbering, and that's more like nomenclature stuff. Cool. Moving right along. Hybridization and bonding. So how many people are familiar with the classic DS game Cooking Mama? Ding dong. So it's just like a cooking little like DS game from people's childhood. That's how I think about hybridization. So I imagine that you put on the counter the s orbital and the 3p orbitals, and you have a big stew that's cooking. And let's say you want to hybridize all of your orbitals. So you put them all in, all 4 orbitals into the stew, it cooks, and then it pops out. And what you get out of it are 4 sp3 hybridized orbitals. So however many orbitals you put into the stew, you get that number of orbitals hybridized coming out. So now let's have all our ingredients on the table again. And in the stew, let's put the S, and let's put 2 of the P's, but keep 1 P out on the counter. So then we are only mixing these 3 together, so we only get 3 hybridized sp2 orbitals out. And then that P orbital that stayed on the counter stays a pure P orbital. And then same thing for sp. But that is my like Cooking Mama metaphor of hybridization, of how to kind of, at least how I think about it. I've also just kind of drawn the geometric layout of what these 4 hybridization states look like with all of the orbitals present. And so here, this is how you get your like tetrahedral geometry. This is how you get the trigonal planar geometry. This is how you get the linear geometry. But I just thought it would be good to visually see it. Sigma bonds are bonds that place the electron density between the nuclei, and then pi bonds place the electron density above and below the nuclei. So they look kind of like this, which is on the next page, of a sigma bond, it's between these nuclei, and then a pi bond, it's above and below. This is all, I'm going really fast because like you all have seen this before, and I know you have, and I'm just wanting to like refresh you and make sure that this feels comfortable. Multiple bonds, every type of bond, double, single, triple, why did I go in that order? Has a sigma bond, and then whatever is beyond that first bond is a pi bond. So like a triple bond is a sigma and 2 pi's. So let's try out this skill builder together where we're going to do a kind of detailed drawing of all of the orbitals and all of the bonds together for this molecule. So take a minute, and I want you to assign the hybridization of each of these atoms, and then I want you to list out all of the orbitals after it's been hybridized on each atom. So, how did you do? Did you get that the carbon and nitrogen, they have 1, 2 electron domains for the carbon? And remember, we have a sneaky implied lone pair here because we can imply lone pairs for skeletal structures. So this nitrogen has 2 electron domains, it's also sp. And then just listing out the orbitals. So hydrogen, it doesn't have any other p's. It's in the first shell of electrons, and so there's only this kind of 1s orbital. Questions on how we got to this point? Okay, so now let's look at the bonds. So we have a single bond here. Is that sigma or pi? A little bit louder? Sigma. Just a little bit more. Sigma, thank you. Okay, and the sigma bond is going to be which 2 orbitals here overlapping? Can someone give me one of them? The hydrogen, S, and then what else? The carbon, sp, exactly. So let's start to draw our picture. We have H, C, and N. And I'm going to make this sigma bond purple. So we have the s orbital on the hydrogen. And then we have an sp orbital, which is like a little big lobe and a little nub. Oh no. Oh no. It's draining the battery very quickly. And so I think that she's starting to freeze. Oh, okay. She's here. Let me know if it keeps lagging like that. Yikes. I hope it doesn't die. Okay, the triple bond here, we know that we have a sigma and 2 pi's. So let's start off with the sigma bond. What orbitals are going to be present and engaged in that sigma bond? sp on the carbon, and then what else? Exactly. So let's make that another sigma bond. And we will see if that happens at some point. Wow, Okay, pi bonds. Pi bonds are between which kinds of orbitals? P orbitals, totally. So, we're going to have one of our pi bonds here between the carbon and nitrogen P, and one between the other carbon and nitrogen P. So, with that, when we make a pi bond, it's going to typically be perpendicular to a sigma bond. So if we are kind of having the horizontal here be our sigma bond, we want our pi bond to be perpendicular to it, like 90-degree angles, if it will show up at some point. Cool. So there's a pi bond. So now, if we have another pi bond on top of that and we want it to still be perpendicular, where should we be putting it? I saw a, yeah. So it's kind of like if this is our kind of x-axis and a y-axis, we need like a z-axis coming out of the page. And so you will see in just a minute, when it loads, what it would look like for the pi bond. Isn't technology amazing?